Hey guys, my name is Yuri Rodriguez, and today we'll be discussing about algorithm thinking in our computer fluency course. This is a very important lecture where we'll lay down the foundations to a proper development of algorithms and do it in a very systematic and precise manner. So when we think about algorithms and we think about our daily life, we most of the time never stop to think about how we actually arrive in our decisions and how it works. They simply happens, right? When you go for a coffee shop, you gotta decide if you want a coffee, a latte, a frappuccino, or any other of the many options you got there. But how do you do it? Had you ever stopped to think about how this process happens? And I'm quite sure never did. I never did until preparing this lecture. And the way that we do it, it's quite nice and it's a quite precise algorithm. So the first thing that you gotta do, you gotta decide among the venues options that you have, right? Where you wanna go to get your coffee. You decided it. So now you gotta decide which drink in that place you wanna have. So among the many options that you have, you picked one, and you got to decide the size of that drink. Are you really thirsty, or you want something really hot? It's too cold right now. So you got to go small, medium, large, extra large. And once you decided about the drink and the size and all these things, you got to make sure you have money. You go to the attendant or cashier, you order it, you pay for it, and you can finally enjoy your drink. So when we stop to break down all the options and process that were involved, you got some steps right, but typically it's so fast and it's so natural that we never actually stop it to think how it actually works. So in this lecture, what we'll do, we'll break down this algorithm thinking in a very systematic manner where we can find the main steps of it. And these objectives will be pretty much define what is an algorithm and how we can actually define it, list and explain the 5 essential properties of an algorithm, and apply a systematic algorithm thinking. So with these objectives and concepts that you have by the end of this lecture, you have a much higher success rate when designing computer programs to solve real world applications. So when we think about algorithm thinking, or when we more precisely think about an algorithm, we expect it to be a very precise and systematic method for producing a specified result. So we want something that works over and over. It works for one specific application that had a previous problem that we were hired or we wanted to solve. And it will have consistent results and in a finite manner. So we'll see it as we move. And first I will present you with some very nice algorithms that we have in our daily life. First of all, you got new furniture. You went to IKEA, you got some nice, very nice table. And you got some assembly directions, right? You got some table legs, you got a tabletop, you got some screws. And you got to get everything together. IKEA does a really nice job showcasing how you got to do it. It has pictures, the steps are sequential, you got numbers for each of these parts. And it's very straightforward, right? It's a very nice algorithm thinking and design. Following, we can talk about recipes. If you get some pasta in the supermarket, you got some groceries that are kind of prepared, they are not completely natural, you typically have instructions in the back. So if you follow them correctly, you're supposed to get a really good outcome. So cooking directions are another example of very precise and systematic methods for solving a problem. Perform arithmetic operations. So when we were younger, we learned how to add, multiply, divide. So we know how to do it. We know 1 plus 1 is equal to 2, 1 plus 4 is equal to 5. We have the same operation, different inputs, but we can have a consistent outcome. And we can also address searching. So when you had your midterm, and let's assume it was printed out, the grades, you go for that student list and you want to find your grades. So if they are ordered by name and your name starts with half to the top letter, like starts with B, you do a top down search. If it starts with an Y, you go bottom up. If it's grade wise and you have no idea, where you are, you kind of go randomly trying to pinpoint where is your place among that list. So these are different ways of seeing algorithms and thinking about algorithms. And we can break down the algorithm constructions in 5 essential properties. So first, inputs must be specified. So you gotta know a specific type of input, the amount of data, and the form that data will be used. When we think about programming and actual computers, we gotta think about integers, charts, and all these different kind of representative ways of data. But this will be a step further. For now, we just want to identify our inputs. What are they? What are them? So outputs must be specified as well. When we do a process, we typically want to have an outcome out of that. It's possible that we don't have, but typically you want to do something to get an outcome. So you went to IKEA, you bought a table, you got all the pieces, you want to assemble and have an actual table. It's got to be precise, so the sequence of steps to be performed must be designed in a way that it can be very precise and hopefully sequential. And if you commit some mistakes in between, you are able to fix it. These operations got to be reasonable and doable, right? So it's the same thing for us on a computer. You got to be capable of doing that. You cannot ask for an engineer to do a brain surgery and not for a surgeon to build a bridge. So you got to ask what people can actually offer. And they got to be finite. So the algorithm must eventually stop, got to terminate after some processing. It can be seconds, days, even weeks, but like it got to eventually terminate. It depends on the problem, but they cannot run forever. It doesn't make sense. So if we think about going back to our daily life examples, if you think about what the shampoo bottle says, so these are our instructions, the algorithm for actually applying your shampoo. So first you apply your shampoo, you lather, you rinse, you repeat. Which one of the 5 essential properties does this algorithm not map? I will give you a couple minutes here, and please use the polling tool that we have in our meetings to record your answers. And refrain to talk with each other for now. We'll have another one that will have a class gathering, okay? So here I would wait for a couple minutes, most like 1 minute, 1.5 minutes. And then after that, with the pooling system that I have available, I would be capable of seeing how the student outcome were given the class, given how the class outcome was, which were the main options that they picked, if they were most on the correct one or they were all over the place. And this would help me guide the pace of the lecture and the points that I should tackle more heavily. So given that, I will assume that they went most of them went to the right answer, which would be finiteness, but some of them were also oscillating among outputs specified and precision. So we'll address some of these issues following on. So thank you very much for your answers. Most of you got it right. It should be letter E, finiteness. But some of you had also some really good comments on the other ones. So outputs specified, this is a really good point. So we see apply shampoo, lather, rinse, repeat. We don't have anything talking about what are our outputs. But since we're doing it in human language, it the medium infers that, okay, you got clean hair, because we know that shampoo should be applied to her. And definitely precision is critical. So again, in human language, it does makes a lot of sense because human has this capacity to infer what we're talking. Like you say, apply shampoo, lather, rinse, repeat. We don't say with what it should, if you should do it with water or 100% pure water. We know that it should be okay with tap water, but for a computer, we gotta be a little bit extra precise on that. And definitely finiteness is the main issue. We say repeat, so if we put it in a computer or if someone goes literal about that, would repeat over and over and over until the bottle is over. And hopefully they would get another bottle and keep doing it forever. So I would go a step further and ask you, how would you adjust this algorithm to meet the fitness criteria? Again, I will give you a couple minutes. Please type down on chat. Now you can interact with each other. And then after this time, I would like if you could point out to the class answer. This would be really nice. And we'll analyze some of the most picked options, okay? So here I would let the interact in the chat for 1-2 minutes and pick up 3 of the main answers that I could see they kind of repeated most, or they were discussing and they arrived on that one. And I would debate a little bit about it and get them interacting. This would be really good to get a sense of bonding with the class for the students. So again, I will assume that they discussed it and the waiting time was over, and I will get some of these answers. I had 3 prepared here, and I will discuss them with them. So guys, I appreciate the time that you took addressing this topic. I see the 3 main ones. I will discuss a little bit about them. So the first one is really nice. So you just took out the repeat aspect, and it's pretty good. If you think about humans, we know that, okay, we gotta apply, we gotta lather, we gotta rinse, and we gotta do it in the whole hair. We don't need to actually go repeat. We can be a little bit more precise about how we're doing it. So we say apply shampoo, lather, rinse, and repeat until applied in all hair. Makes a lot of sense. And we can go a step further and say we should repeat it until applied in all scalp and hair, right? If someone is bald and they're using shampoo, we got it covered. So if you think of as a computer, the last one is way more precise and it would have a better outcome most likely when implemented in a computer programming. So here I will present you with another algorithm. This one is quite nice. This one is Mr. Noodles. So instant noodles are a really go-to option when you are tired and you need some really fast food. And you expect that the instructions of these are really simple, straightforward, and you cannot miss. And they kind of deliver on that. So if you see the cooking directions, you got 3 main states. And I would like your help here to define which would be the inputs, the outputs, the precision, reasonable operations, and finiteness, if these instructions actually attend all these steps. So again, here I would interact with the students. I would try to get their inputs to fulfill these boxes. I really think that algorithm thinking should be a really interactive lecture. So, but again, since we don't have the students to interact here, I will do it by myself, assuming that they were interacting. So first, for input specified, I think we all of us agree that we got noodles, we got 2 cups of water, we got soup base. The output is pretty much straightforward. We can infer it. It doesn't need to be written. So we got cooked noodles. Instructions are really precise. So you boil water, you cook noodles for 2-3 minutes, remove from heat, add soup base, stir. Perfect. Again, they are pretty much reasonable. Operations are super doable and they are finite. So yes, this process terminates. Once you did these steps, you got your noodles, you're ready to eat. Now here, I would love if you could gather together. So break you in groups of 5. I will have you in breakout rooms now, and I will give you 5 to 10 minutes to discuss about how you can provide an algorithm for brushing your teeth. Here, I'll give you some tips. So please, remember, once you have the algorithm done and ready, see if it meets the 5 essential properties of the algorithm. So you got specified inputs, output, is it precise, the operations are reasonable, does it have finiteness? And please, once you are done with that, submit to our learning management system online, go to the Canvas web page. There is an assignment option for this class, and you should associate this outcome in your group. So each one of you get the programming that you have, please generate a PDF and associate in our Canvas. So here again, I would allow the students some discussion time. I would go in different breakout groups at different moments and ask for then how is their progress to keep them working. But again, I will assume that we are over this step and I will move on. So guys, you did a really good job. Now here I will just present a generic solution, and I will point out, I will actually extract some of this information and let this for you guys to analyze at your place and compare with what you got, okay? And this finally leads us to how we can implement this algorithm thinking in a computer-based environment. So we know that an algorithm must be written using a language understood by both the writer of the algorithm and the reader who will use it. So we were talking about noodles, shampoos, and how you order a coffee. So we were talking about human algorithms written in human language. So in this case, English for a human reader, right? This works quite nicely for us because we're using natural language, in this case, English. So these languages are often ambiguous and they require domain knowledge and context. When we're talking about shampoo, we never said that you should be in a bathtub or whatever to be applying it, or which kind of element you should use to rinse or not. Like, you know that you should be in your bathroom, you know you should be using water. And all these informations, they pertain to the domain of knowledge and context of human being living, right? Still, if we think about this in a computer language or a computer environment, we need to be way more precise. So for this, we need programming language. So these languages, they provide a consistent domain of knowledge without context, inference, or requirements. If you think again about how we interact as humans, we know a lot of this information from our living. Computers don't have that experience, they cannot infer. So we gotta provide them with very precise information in a consistent manner. And we can only achieve that using programming language. These languages, they will provide the backbone and the structure that we need to actually communicate effectively with computers and be able to solve complex problems. Here, I would like to let you know, so it is natural that it's problematic once you do the transition because we have some issues with precision. Again, we have algorithms all over the place. We execute a lot of them during our daily routine. But it's natural that when we do the transition, we miss some of these steps. Because of this, it's very important that you dig in and actually analyze these 5 steps. So as a conclusion, remember that an algorithm is a precise sequence of steps to produce a result. A program is an encoding of an algorithm in a language to solve a particular problem. So this is the next step that we'll be doing in our next lecture. You get our algorithm knowledge and transform it into a program that a computer can understand. And for that, we need 5 essential properties so we can actually be successful when doing a program in a computer language. So we got to do input specification. We got to know our output. We got to be precise in the instructions, how these steps should be performed. These operations got to be reasonable, and we got to make sure that we meet niceness criteria. With this knowledge, we conclude our class, and I would highly suggest you to go to our online learning management system, so our Canvas webpage, so you can actually find today's lectures handout, especially the step that we have, so you can compare this solution that I posted for the toothbrush algorithm with the one that you develop. Please take our algorithm thinking online quiz. It will be doing 1 week, and get ready for our lab. So the manual and tutorial are available and it should happen next week. If you have any questions, please use one of the following options. You can open your mic and let me know. You can send me a message through the chat, or you can email me and schedule an appointment during this week, okay? It was a pleasure having you guys here. If you still have any questions, please stick around. So now I will take my students' questions, and once we wrap up The class would be over. For those that were ready, they would be leaving, and I would terminate my class. Okay. Thank you very much for your time. I hope you enjoyed it.